All right, this is Algebra 2. We're doing our checking our understandings from September 19th. We were trying to find a formula for this first sequence, and I'm noticing that every single time I'm going to the right, I'm adding 7, I'm adding 7, I'm adding 7. Mr. Sindel is not trying to trick me. So that means that we have, so I can do the this implies symbol. This implies it's an arithmetic sequence. And I remember that arithmetic sequences, they have some start number. So I'm going to say f of x is equal to some start number. And I can start wherever I want. I can start at 10. Sure, why not? 10. And then I'm going to add on a shortcut. So I'm going to add on a multiplication shortcut because the repeated addition, the shortcut for repeatedly adding 7 is multiplying by 7. So I can say 7 times, okay, and then how many copies of that do I have? And I know that I'm always going to have to do x minus that place value that I have. So this is the first number, that is the second number, and that's the one that I chose. So if I chose the second number, that place number 2 goes down here. The 10 came down here for that number that I'm starting with. But because I'm in the second place, let's come down here and say this is spot number 2. And I'm done. And I always check my work. I want to make sure I'm doing this right. So this is me checking the sanity check. If I do f of 3, I should get the third number, right? Because that was the third number up here. So I'm going to say, okay, if I do that, I get 10 plus 7 times, plugging in now, 3 minus 2. And doing some really quick mental math, that's going to be 1. 1 times 7 is 7. 7 plus 10 is 17. So all of this is going to eventually add to 17. And hey, this is saying that the third term is 17. And look at this, the third term is 17. So that works. Check. And that's the answer for number 1. What about number 2? So I'm noticing on this first one, I would be adding 20, adding 20. Oh, okay. If I add 20, I should get 50 there. Okay, maybe am I multiplying? Let's try that. So take it from here to here. I'm multiplying by 3. Oh, yeah, so multiplying by 3, and 9 times 3 is 27, so 90 times 3 is 270. Excellent. Okay, so if I'm repeatedly multiplying, this implies that we're dealing with a geometric sequence. And if we're dealing with a geometric sequence, I know that that formula is generally f of x is equal to some starting number. So, oh, well, both of them start with a 10. Oh, okay, I can choose whatever number I want. Let's randomly choose 90. I don't know. Again, it doesn't really matter which of the numbers you start with. I just randomly said, oh, well, sure, that one, why not? So I'm putting that as my first number, and notice that that is in the third spot. So I'm going to go ahead and say that's the first spot, the second spot, the third spot, the fourth spot. So I'm starting with the third spot down here. That'll affect us later. Okay, and now I'm going to multiply, because everything in here is going to be multiplication. I'm multiplying by 3, multiplying by 3. Over here, I was adding, repeatedly adding, which is why I have a plus sign. Over here, I have repeated multiplication, so multiply, 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 right? And the shortcut for repeated multiplication is I want to say multiply by 3, multiply by 3, multiply by 3, and that will eventually get me to wherever I want to get. But the problem with multiplying by 3 is it takes a long time to write, so there's a quicker way to write that, and that's 3 to some power. So I'm going to say times 3 to whatever power I want, so x. And the problem with that is I need to fix this by subtracting whatever place I had. So if 90 is in the third spot, 1, 2, third spot, right, then this is going to be x minus 3. 90 is the third spot. These two numbers kind of match up. So I'm going to say x minus 3. And there it is. The formula's done, but let's test, right? So let's do a check. So if I plug in a 1, for example, that's kind of a harder number to do because I'll have negative powers, but I still want to try it. So f of 1. If I do that, I should somehow get my answer. The first value is 10. Somehow I'll get a 10 out of this formula. So here we go. I'm going to rewrite the formula. 90 times 3 times 1 minus 3. Okay, so do some simplification. This is going to be 90 times 3 to the power of negative 2. Okay, that's going to be 90 times, okay, 3 to the power of negative 2. If you remember this rule, it's going to be whenever you have a negative power up here, you're going to flip it. So it used to be 3, I'll show you. It used to be 3 over 1. I'm going to flip it, so it's now 1 over 3. 1 over 3. And now I'm going to make that power a positive 2 in the denominator, in the bottom. So if I keep going through that, this is now going to be equal to 90 times 1 over 9. And I'm running out of room. This is going to be 90 over 9, and that is 10. That's the answer that I wanted to get, right? Because that is the first number. Thank you. Even. So 10 does match up as the first number in our sequence. The first number is 10. The first number is 10. There it is. Cool. So we did our sanity check, and we are done with the checking your understanding problems. Thanks for watching.